Imagine being thrown back in time, stripped of all modern technology. No power tools, no internet, just your hands and your wits. How would you survive? How would you rebuild civilization? Today, we're diving deep into a forgotten skill, a monumental task of craftsmanship from a time when ingenuity was the ultimate survival tool. We're going to witness the creation of a watermill shaft, carved by hand, just as our ancestors did. This isn't just about shaping wood. It's about harnessing the power of nature, a skill that could mean the difference between life and death in a post-apocalyptic world. Our journey begins in the heart of the forest. The first and most critical step is selecting the perfect tree. We're not looking for just any timber. We need a giant, a colossal oak, straight-grained and free of knots or defects. This single tree will become the heart of our machine. Its sheer size is intimidating. Felling a tree this massive, with only hand tools, is a battle of endurance and precision. The rhythmic chop of the axe, the steady rasp of the crosscut saw, is a symphony of human effort against the quiet strength of the ancient woods. Every swing, every pull, has to be deliberate. A mistake here could ruin the entire project, or worse, cause a fatal accident. As the giant finally groans and begins its slow, majestic fall, the ground trembles. The real work has only just begun. Now we face the challenge of moving this multi-ton behemoth from the forest floor to our workshop. Without engines or cranes, we turn to the genius of simple machines. Levers, rollers, and sheer muscle power. It's a slow, grueling process, a testament to teamwork and raw determination. Each inch the log moves is a small victory, a step closer to turning this raw material into a source of sustainable power. This is the kind of problem-solving that defines survival for generations. It's about understanding physics not from a textbook, but from feeling the strain in your muscles and the resistance of the earth. With the log finally at the worksite, we begin the painstaking process of shaping it. This is where true artistry meets engineering. First, we need to debark the log. Using a draw knife, we peel away the rough outer layer, revealing the clean, pale wood beneath. It's a satisfying, almost therapeutic process, but it's just the prelude. The next step is to square the log, transforming the round trunk into a massive, 8-sided beam or an octagonal prism. This isn't for aesthetics. It is a crucial step for accurately marking our center lines and ensuring the final shaft will be perfectly balanced. We stretch a chalk line from end to end, snapping it to create perfectly straight guidelines. Then, with a broad axe, the real sculpting begins. This tool, in the hands of a master, is an extension of their will. It's not about brute force. It's about control, rhythm, and reading the grain of the wood. Each swing removes a slab, slowly revealing the squared form hidden within the round log. The air fills with the sharp scent of fresh-cut oak and the percussive sound of steel meeting wood. It's a dance of power and precision. An unbalanced shaft would vibrate violently, tearing the mill apart. Every cut must be perfect. Now, we transition from squaring the log to the most challenging phase, making it round again. This might seem counterintuitive, but the initial squaring was essential for accuracy. Using a template, we mark out a perfect circle on each end of the massive beam. The goal is to connect these two circles, carving away the excess wood along the entire length of the shaft. This is done with a variety of hand tools. The adze, a curved blade axe, is used for rough shaping, its rhythmic thwack echoing as it bites into the wood. The craftsman stands astride the log, swinging the tool between their feet in a move that demands immense skill and trust in their own abilities. One slip could be disastrous. As the shaft gets closer to its final cylindrical shape, we switch to finer tools. The draw knife and the spokeshave come into play, smoothing the surface, removing the tool marks left by the adze. This is where patience is paramount. We're not just making a cylinder. We're creating a surface that will rotate smoothly for decades. We constantly check our progress, using calipers and straight edges to ensure uniformity. Is it perfectly round? Is it straight? The slightest imperfection could compromise the entire structure. This process is a conversation with the wood, feeling its texture, listening to the sound the blade makes as it glides across the surface. It's a level of connection to the material that modern manufacturing has lost. With the main body of the shaft complete, we focus on the ends. These are the journals, the parts that will rest on the support bearings and rotate. They must be incredibly smooth and perfectly sized. We use files and rasps, and even pieces of abrasive stone, to polish these surfaces to a near-perfect finish. Any friction here means lost energy and increased wear. It's meticulous, detail-oriented work that can take days to complete. While one end is being polished, the other is being prepared for the gudgeon pin, a heavy iron spindle that will be driven into the center of the shaft. This pin is the critical connection point, the axis on which everything will turn. Driving the gudgeon pin is a moment of high tension. The hole must be drilled perfectly, and the pin itself must be seated with tremendous force, creating a friction fit that will never loosen. We heat the pin until it's glowing, causing it to expand. Then, with heavy sledgehammers, we drive it into the end of the oak shaft. The smell of scorching wood fills the air as the hot iron burns its way in. As the metal cools, it contracts, locking itself into the wood with an unbreakable grip. This fusion of iron and oak creates a hybrid component, combining the strength of metal with the resilience of wood. Finally, the moment of truth. The finished shaft, a masterpiece of manual labor, is ready to be installed. Lifting it into place is another monumental effort, requiring careful coordination and the use of block and tackle systems. It's gently lowered onto its stone bearings. A hush falls over the workshop as we give it the first tentative push. It moves. It rotates smoothly and silently. The balance is perfect. The slight shush of polished wood on stone is the only sound. It's a moment of pure triumph. Months of backbreaking labor have culminated in this single perfect rotation. This Watermill shaft is more than just a component. It is a symbol of resilience, of human ingenuity, and of a deep connection to the natural world. It's a technology that can be built, repaired, and maintained with skills passed down through generations. In a world dependent on fragile supply chains and complex electronics, knowing how to build something like this is the ultimate survival skill. It's the power to rebuild, to create energy from nature, and to sustain a community. This is the knowledge that helped our ancestors thrive, and it's knowledge that we should never forget. Thank you for joining us on this incredible journey back in time. If you found this glimpse into forgotten craftsmanship as fascinating as we did, be sure to like this video and subscribe to our channel for more deep dives into historical survival skills. Let us know in the comments what ancient technology you'd like to see us tackle next. Stay curious and stay prepared.